Good evening everyone. So this is the last interactive session, that is week 12 for the course on Introduction to Multimodal Urban Transportation Systems. So as we have done for the other 11 interactive sessions, so we will start with some numerical as well as some theoretical questions, right? So are you able to see my screen? Can you tell me that you are able to see the PPT? Yes, good evening. Okay. So then today there are 9 questions including numerical and theoretical. So let's start for today. So first one is of numerical type. So it's about stopping distance. So the question is, a driver in a car on a residential street is traveling at 60 km per hour, and then he puts the brake when he sees a stop sign, right? So then the coefficient of friction, that is mu, that is given as 0.40, and the acceleration due to gravity is given as 9.8 meter per second square, right? And also the speed is given. So what is the stopping distance of the car? So you calculate and tell me what is the answer, as it has no options. So just calculate the stopping distance. I think you know the formula, or do I need to write the formula? Okay, I calculated my answer. You tell me what would be the stopping distance of the car, that is what is the minimum distance that is required for the car at which is traveling at 60 km per hour to come at 0 km per hour, that is come to a full stop, right? So what is that distance? Tell me. 35.44, yes. Okay. So then the answer is 35.44, right? Meters, obviously in meters. So then it is given that there are 4 land uses, right? First is water, then agriculture, then residential and industrial, and you have 15 counts for water, that is 15 pockets of water, then 15 for agriculture, 8 for residential, and 11 for industrial. So for a area, this is the 4 type of land uses, right? So now you need to calculate what is the entropy index of that particular land use mix. So you tell me what will be the entropy index. So what was the formula? The formula of entropy index was what? Minus 1 into probability of each land use into ln of that Pj, and it is divided by what? Divided by ln of J, the type of land uses. And here, so this is for 1. Now you need to use the summation, right? So I am not writing the full formula, right? I need to go to that insert equation and then need to add this summation. So I am not doing it. So but you calculate and tell me what is the answer. I hope that you are also calculating. Whenever it is done, you comment. And ranges. So these are the values of Pj, these are the values of ln Pj, this is the value of lnj, right? So is it done for you? Okay, you are saying 0.9733. Yes, it will come close to 0.9733 only. So okay, I am not calculating it further, but these are the values, right? So now it's a related question. So the question is, at what situation entropy index can be 0? So you know the formula, right? So now you tell me when this value will be 0, at what condition? Like just think that at what situation it can be 0, right? So this time you got the answer of 0.9733, right? And now just think that how it can be 0, considering the formula and considering here is a summation is there. Now tell me what is the, how it can be 0, tell me what could be the context at which it can be 0. Just think that how it can be 0. Lower mix level, how many mix? Lower mix means how many mix? So suppose if you have two mixes, I am saying that suppose you have two mixes, so then your probability, suppose let's say it is 0 0.6 and 0 0.4, right? So 0 0.6 into ln of zero point 0.6 by ln of 2 plus 0 0.4 into ln of 0.4 by by ln of 2. So it is not 0. It will not be 0 even if your land uses are 2. You can calculate whatever you feel that probability is 0 0.6, 0 0.8, 0 0.8, 0 0.2, 0 0.6, 0 0.4, because ultimately your probability should be 1, right? If you add the probability of two land uses, here also our probability was 1 if we add the 4 values of these land uses, right? So you are close, but even if land uses are 2, only suppose water and agriculture, then if the values are remain the same and these are not there, suppose, then also your probability is 0.5 and 0.5, right? 15 by 30, 15 by 30, 0.5 and 0.5. So then also you calculate. So 0.5 into ln 0.5, what is the value of ln 0.5? ln 0.5 has some value of minus 0.693 into 0.5, and then you have a minus 1 outside. Okay, let it be outside because it will be positive. So then it is 0.346, your 0.346 into 2, right, divided by your ln2. So then your value was 1, it is not 0. So the thing is that suppose your this value is 0, what is in the numerator, right, not in the denominator. Suppose it is has some positive value, and it is this ln pj is totally 0, then it can be 0, or if your pj is 0, right? So suppose suppose you have only one mix, one land use, right? So then what will be your probability? Probability will be 1, right? And then what is your ln of 1? Ln of 1 is 0, and then also it is undefined, it is also not 0, right? Because your ln also, j is a type of land uses, also 2. So even if I do it 1, it is not 0, but this ranges, entropy index range is between 0 to 1, right? So obviously in case of lower mix level, but it should be some special case where it can be 0, because otherwise it cannot be 0, right? So just think about it, what can be the situations. So let me go to the next one. It is just for your thinking, just you think that what could be the special situation that in real life that can happen, right? So then the next one is providing buffer reduces pedestrian exposure to vehicular traffic, true or false? So if you are providing buffer on roads, is it that it is reducing the pedestrian exposure to vehicular traffic? This statement is true or false? It is true, as you have rightly mentioned in the chat box also. So because you are providing buffer so that your those two traffics will be segregated, right? So that's why it is true. So okay, then let's not waste time and go to the next one. So which of these parameters help in determining the vehicular emission? Vehicular technology, fuel quality, is it the road and traffic management, or is it the all the options are correct? What is the right answer? So vehicular emission is affected by which of these following options? Is it influenced by vehicle technology? Is it influenced by fuel quality, of fuel? Is it influenced by road and traffic management? Is it influenced by all of these factors? Okay, so let me just spend a minute or two, because here vehicle technology, it is referring to the BS3 to 4, those kinds of things here. These kinds of thing it is referring, right? Then your fuel quality, suppose fuel type is a different thing, petrol versus diesel, because diesel are more polluting than the petrol, right? But here suppose you add uh, kerosene, right, on your diesel or petrol, still if you add it in a certain proportion, still your vehicle will run, right? But then your engine will emit more gases and more toxic gases particularly, right? Also there is a chance that your engine will be uh, this, your durability of the engine also will get reduced, right? Then how your road and traffic management will uh, affect the vehicular emissions? So traffic management means, suppose you have a unsignalized intersection versus you have a signalized intersection. So suppose in a signalized intersection, it is necessary for you to make queues, right? So you need to stop necessarily. So because of the stop and also in the unsignalized intersection, you have the situation of stop and go, stop and go. So accelerate, decelerate, accelerate, stop. So those situations actually will increase your emissions. You cannot say that your signalized intersection always be more polluting than your unsignalized intersection, because it will be based on the traffic scenario, right? And also the particular road, so based on the uh, pavement surface and other things also, it will also depend on the emissions, right? So then it is the right answer, right? So now let us go to the next one. So what is the bicycle crash frequency for a 2-lane undivided road where your limit is 30 only? So you have a predicted average crash frequency already, you have predicted, but you have not considered pedestrian or bicyclist, right? Now you want to predict, because maybe you want to allow bicycles to run on the same road. So now you want to uh, predict what could be the bicycle crash frequency, right? Already you have calculated your crash frequency without the presence of bicycle and pedestrian. So then already the chart is given, so just calculate and tell me what is the answer. Tell me. Hmm. 0.096, maybe 0.10 or something if we round it off, but okay, that is the answer, right? So you just need to multiply your factor with your already predicted average crash frequency, right? So that will give you the correct answer. Okay, so now tell me, environmental impact assessment for transportation projects is least effective when conducted at which state? So as you have already went through this week 12 lecture notes as well as the video, so EI is necessary, right? So what is the environmental impact at pre-construction stage means before constructing, what is the current scenario, how how it is affecting the environment in terms of maybe pollution, in terms of maybe cutting of trees and those things, what is the current status. Then for construction, what are the major impact, are you cutting the hill, so how it will in future affect your environment, right? So those things has to be taken into account. Then in the operation stage also, what could be the other, because in the operation stage, what will happen, more and more vehicles will flying, because you are constructing a road, because it's a transportation project, then your emission will increase. Already you cut your trees, so how do you do that environmental impact assessment, right? So now you are doing after constructing a new road, so then it is not that effective, right? So it's already in the post construction stage, so it is not that effective. So okay, let us go to the next one. So now a 3-mile section of a road has witnessed 15 crashes over 4 years and a traffic volume of 12,000 vehicles per day. What is the crash rate? So it is not the crash frequency but the crash rate. Tell me, what is the crash rate? You have a 3-mile section of a road and you saw that, suppose it's a black spot kind of thing, so you saw that already 15 crashes is happened or occurred over 4 years. So based on the guidelines, I think it can be considered as a black spot, this section of a road. So then you have a traffic volume of 12,000 vehicles per day. So then what will be the crash rate? Okay, so you have calculated, maybe I need to calculate. So 12,000 vehicles per day for 4 years, 365 days into 3 mile section. So it is this, and then you divide this to this. So it is coming out 28.538, means 28.54, right? 28.54 crashes per million vehicles mile travel, right? Also that's what you have also said, so A is the correct answer. So now tell me, in avoid shift and improve approach, avoid caters to increase the efficiency of what? Trip, system, vehicle and none of the above. What would be the correct answer, right? Avoid shift, improve approach. So okay, so basically what this approach essentially tells you, that you need to avoid or you need to reduce the demand for your travel, right? Because if you don't reduce your demand for travel, suppose example is work from home, or maybe some kind of uh, maybe work from home for 1 day or 2 day in a week, like that. So you already reduce your demand for travel. So as you have reduced your demand for travel, now your overall system will be stable, right? So your efficiency will be higher. Then what is the meaning of shift? So now what transportation people want you to take the not private mode of transport but the other mode of transport, maybe public transport or maybe bicycle, maybe walking. These are called as the sustainable mode of transport, right? So what those things will do, the shift. So shift caters to what efficiency? If I would have asked you that like avoid caters to increased efficiency of system, you are saying. So now I am asking you, the shift is affecting which kind of efficiency? Tell me. So now you are shifting to other sustainable mode of transport, right? So now how your efficiency will be affected? What kind of efficiency will be affected? Is it the overall system again? Is it the vehicle efficiency? Is it the trip efficiency? Or is it that something else? tell me. Just think logically what could be the answer, because in case of avoid you are directly saying system. That also you should understand that how you are saying that whole system, because in avoiding or reducing your travel demand you are impacting the overall transportation systems. So that's why it's a system efficiency that will be increased. Now you want to shift other people to sustainable mode of transport. So suppose, so see, these are efficiency not in terms of only your reduction in travel time, right? It is uh, because this module is about environment and energy conservation, right? So it is taking into account those factors, not that your travel time will be faster only, right? So in that aspect, so your trip efficiency means your trip is not affecting that environment that much, energy consumption is less, your noise pollutions are less, right? So that's why even if I want you to shift to a sustainable mode of transport, for those trips are become more efficient than your private vehicle trips that you are generally doing, right? Because I am able to shift you to a better mode of transport. It may be a bus or train also, that is also a sustainable mode of transport. Even that also increase your trip efficiency. So if we understand the avoid and shift thing, now you say what does it mean to improve? What do you mean by improve, and what kind of efficiency it will increase? Improve means what? Yeah. Avoid means reduce your travel and do not travel. Shift means shift to a better mode of transport in terms of sustainability, right? Now what we need to improve? What do you think? What is the meaning of this improve? What is this improve? What do you think? Just write that I think that improve might be this, related to this. So if we improve the energy efficiency, no, see, everything is improving your overall energy efficiency as well as your environmental criteria, right? Your this avoid, shift and improve, this concept is based on the overall energy, environment, those kinds of improvement. Based on that only this is what they are taking this approach. So obviously in avoiding your or reducing your travel, already you are reducing the private mode of transport also, right? So that is also improving your energy as an overall transport network. So now if you are shifting to better mode of transport, so then also it is improving your energy, right? So now this improve means, so suppose even if you are able to reduce your travel demand, second is able to shift some people to better mode of transport, still you have some people or somebody who are using the private mode of transport, or even if you are even if we are using the bus, and maybe we are putting the diesel oil, right? So we need to improve our uh, uh, engine in such a way that it will reduce the overall maybe fuel efficiency, it will improve the energy efficiency, it will improve the, because it will less polluting, right? Suppose we upgraded our BS2 to BS6, and then we upgrade some of the vehicles to electric vehicles rather than the normal vehicles, so then your vehicle efficiency will be higher, right? As a part of vehicles your efficiency will be higher, so we are targeting the each vehicles. So like, are you getting the point that why avoid is linked to the overall system means everything, right? And why your shift is only restricted to your trip efficiency, and why is it your improve that is related to your vehicle efficiency. Improve means improve the existing vehicle or vehicle engine basically, for the overall improvement of energy efficiency, whatever you are saying, right? So this is what your avoid, shift and improve is all about. So whenever you are doing, or suppose you are submitting an assignment in NPTEL or anywhere else, maybe you know that avoid is related to system efficiency, but you should inquire that what are the other terms or other related questions. So that way what will happen, you will like the things will be better clarified, because you are comparing your immediate knowledge to the other ones that you are in doubt, right? So shift and improve, you are in some kind of doubt, right? So that's what my suggestion would be. So this week, this is the last week, so I would thank all the participants who have joined or maybe seen these videos in YouTube throughout these 12 weeks, right? So also I would like that if you want to say something about anything about the related to the course, related to the course content, if you have any queries or if you have any suggestions also, it is welcome from all of you, right? So you can ask anything. So today I keep it short because it's not an heavy module also, and also the things are mostly straightforward, but still if you have okay. So one question, that in question 12 of week 12, okay, can you tell me what is the question 12? Okay, maybe I was having that question, if it is matches with your question. 12. Okay, tell me 12, what is the problem? Tell me. To calculate, okay, tell me. What is the exact problem? Okay, the answer is 2 point, but there is, okay, okay, so okay, so are these are values are same, 40 kilometer road from a mixed traffic and 10 trucks and 16 cars and 20 two-wheelers are there. Is it the same, the number? Just can you confirm that these are the same numbers, because I don't know if these numbers are same in case of your actual assignments that is given. Same, sir. Okay. Okay, now your these are also same, I think. Then CO truck, CO car, and CO two wheeler of this 4 1 and 0.75, right? Grams per kilometer. Okay, I think this is also same, 4 1 and 0.75. So now your 10 16 and 20, 10 16 and 20, okay, 10 16 and 20, and your 40 is the kilometers, okay. Then 4 1 truck, 10 into 440 is the truck, plus 16 is the your car, then 20 is your 0.75, so that is 71 into your 40 kilometers. Okay, so it will be come out to be, so you are saying that the answer is 2848. 2848, that's what. Okay, maybe my okay, 2840. Yes, actually it is coming out to be 2840. Let me check that why it is a problem here. Okay, let me wait 1 second. This is E. Okay, got it. So 10 into 40 means 10 into 40. Okay, okay, okay. 10, 16 and 12. Okay, 10, 16 and 12. And then 4, then 1 and 0.75. Okay, let me calculate from here also, so that we don't make mistakes. 10 into 40 into 4 plus 16 into 40 plus 20 into 40 into 0.75. Okay, 2840. Okay, then the calculation is wrong, so you are correct. So did you message in the discussion forum? Do you like, no? So okay, that is that is okay that you messaged here, but I will inform the relevant authority about this problem. But I would also like you that you just give a message in the discussion forum that already I have discussed with the live session whoever is conducting, and that is the problem, because see, these are the things that is done automatically. So also let me go to check what are the options. 3, 5.2. Okay. So the problem is it is automatically given, right? So it is usually checks by computer, it is not manually checked. So whatever we send as the correct option, so based on that it is checked. So we cannot say that you can choose any option right now, right? So the best is we will re-evaluate whoever is sending these questions. So what we do, we just inform the relevant authority, so they will re-evaluate your this question, right? So either they will give marks to everyone, otherwise they will just remove the questions from the evaluation, like that they are doing. So I would like you that you should send a message in the discussion forum that this is the question, this will be the answer. I think the values that are given are not there in the options. Also I have discussed with the discussed in the live session that was conducted for this week. In that way you can just send a message, and also I will do my part by giving by telling them that you should reevaluate this, right? Okay, so one participant has joined right now, but already our session has been ended. So if you have anything to ask, then only so these are some simple questions that we already discussed, right? So if you have anything from any week or from this week, you can ask, right? Because this is the last interactive session, that is week 12. We although discuss something, mostly these are easy, and I think you will also able to calculate. First one is the about the stopping distance, then the entropy, what is the range of entropy, and then the what is the use of buffer, right? So then how, what are the parameters which are basically are helping in determining the vehicular emissions, right? So then calculating bicycle crash frequency from the predicted average crash frequency of the existing road. Then what is the EIA, how it is affecting the different stages of constructions, right? So then how do you calculate a crash rate if your section of the road is given, that is the length of the section is given, and your crashes also is given, and then your traffic volume is also given, right? So it is also straightforward. So then in avoid, shift and improve approach, what is the meaning of avoid as well as shift as well as improve, right? So these are the things that we already discussed in this session. So if you have anything more, you can ask, otherwise we will meet in future. If you take any other course and if I am there, so maybe we will that time, and if you have any suggestions or any clarifications also, you can ask, and you also you can comment here, right? And if not, then you can say, and we will close it for this MUTS 2022 course, right? Tell me, I want to hear from you. Okay, Prajwal has already said that he has no doubt. I think another participants also, you can say if you want to say something related to the overall course as well as the live sessions as well as anything. If you want to say or comment or suggest anything, you can comment. No? Okay, actually these are the main intentions, so that participants uh, are having no problems with solving the assignments and also for the nearby exams, right? So best of luck for your exam, right? So we will close it, right? Thank you for joining in.